Assalamualaikum warahmatullahi wabarakatuh, my dear students. While doing the video for Hess Law, I was thinking, will you be able to answer the practices for concept of enthalpy? So I want to give you how to answer questions on combustion, because in the example the question is on neutralization, enthalpy of neutralization. But what about enthalpy of combustion? For A plus students, they will be able to do it because of good thinking skills. But since everybody is still in the holiday mode, I will give you one more example to show how to answer questions on enthalpy of combustion. Okay. In an experiment, 0.1 gram of hydrogen gas. Look at that, you are able to find the number of mole for hydrogen gas. It is compressed into a 1 liter bomb. So the amount of water in the calorimeter bomb is 1 liter. It is then placed into a calorimeter that has a heat capacity of 9.08 times 10 to the power of 4 joule per degree Celsius. So heat capacity of calorimeter is given to you, the capital C. And the initial temperature is 25, the final temperature is 25.15, the delta T would be 0.15 degrees Celsius. Calculate the enthalpy of combustion. Okay, firstly, you need to write down the equation for the combustion of hydrogen. So, this is H2 gas plus half of O2 gas becoming H2O liquid. This is the balance equation, but it is not yet thermochemical because you need to find the delta Hc to put at the back of this equation. Okay, the next step is you find the number of mole of the hydrogen gas. So 0.1 divided by 2 grams per mole, you get 0.05 moles. Okay, so the formula that we are going to use for this question, because it used calorimeter bomb, which has water in the calorimeter, we are going to use Q equals to MC delta T plus C delta T. Q equals to M. M here is not the M of hydrogen gas, because we are not measuring the heat released by the burning process of hydrogen, but we are calculating the heat absorbed by the water and calorimeter. So the M here is the mass for water in the calorimeter. The C is specific heat capacity of the water, and delta T is 0.15 degrees Celsius. Capital C is 9.08 times 10 to the power of 4. This is the specific heat capacity of the calorimeter depending on the material, whether it is aluminium, ferrum of some sorts. And then 0.15 is the delta T. It's the same with the previous one. Okay, so when we press the calculator, we are going to get the big number here because it is in joule unit. But the unit for enthalpy is not joule, it is kilojoule. So we convert it into kilojoule. Right. Previously, we have calculated the number of mole of hydrogen gas is 0.05. This much of number of mole produces 14.247 kilojoule. So how much is the energy used when we have 1 mole? Now, it is calculated to be 284.95 kilojoule per mole that is needed. Now, the final answer is delta H combustion for hydrogen gas is negative 284.94 kilojoule per mole. So the question can also be asked like this. Instead of asking what is the enthalpy of combustion of H2, it can also ask you what is the enthalpy of formation of H2O, because the product there is H2O, right? So what we're going to do is we are going to look at the balance equation. 1 mole of H2 will produce 1 mole of H2O. Therefore, 0.05 mole of H2 will produce 0.05 mole H2O. It's a coincidence that there is 1 mole equivalent to 1 mole in this equation. But if it's different, then you have to multiply by certain stoichiometric coefficient that is established from your balance equation. So ultimately, the final answer is going to be the same. Negative 284.94 kJ per mole is the enthalpy of formation for water in this question. I am giving you here the tutorial questions at the back of the thermochemistry chapter in your coursebook in order for you to do in your own time. This is small, question number 3, 4, 5, and 6 regarding on how to get the enthalpy of combustion for number 6. For number 5, you need to find the delta T. And then for number 3 and 4, you can even answer after you have finished watching the first video of the semester. Here are more questions. So I give to you up until number 10 only so far. Question number 7 is asking about heat capacity of the bomb calorimeter. So you would know straight away what is the formula that you're going to use. So you're going to find capital C. Question number 8 is almost the same as example 1.5. It's just that you need to find the limiting reactant first for the neutralization reaction. And then question number 9. This happen always in the kitchen. I tell my daughter, if you want to boil water or if you want to cook something, you need to estimate which kettle or which pot is suitable for that amount of food. For example, I want to do my pudding telur. Consists of 10 eggs, 1 can of creamer, 1 can of evaporated milk, and then I need to know the mass of the thing that I want to steam so that I can predict how much water do I need, and given the time, I can estimate how much gas that must be burnt. So if you want to go camping, for example, you want to know how many can of butane are you going to bring? You can estimate how many times am I going to boil water for tea, or how many times do I want to make Maggi. So I maybe need only 2 can. I don't need to bring the whole box. So this knowledge is actually important for the survival of us in our daily life. So you need to find the mass of gas that is needed to burn that 2 kilograms of water in the kettle. So this is the importance of learning about thermochemistry. Okay, question number 10 is on coffee cup calorimeter. So this would be neutralization also, the same as example 1.5. So good luck everybody. All the answers, all the final answers are there. So please help yourself and do the work on your own before asking for the explanation from us, your chemistry teachers. Thank you very much for watching and enjoy learning. Assalamualaikum warahmatullahi wabarakatuh. Bye.